Let's take a look at scientific notation. The basic form of scientific notation is some number a times 10 raised to an exponent. Okay, this exponent could be any integer. So it could be positive or negative. Okay, but this a could equal 1, or it could be greater than 1. But it has to be less than 10. Okay, also, it could be the negative. So it could go from -1 to -10, and it could equal -1, but not -10. Let me give you an example of how we get into this form. So we have the number 9 million. 9 million is really 9 times 1 million. And 1 million is really 10 to the 6th. So 9 million could be rewritten in scientific notation as 9 times 10 to the 6th. So let's look at another number. Say 5,000. It's really 5 times 1,000. And 1,000 is really 10 to the 3rd. So this is really 5 times 10 to the 3rd. We had 1,400. This could be written as 1.4 times 1,000. And in this case it would be 1.4 times 10 to the 3rd. So if we look at all of these, they're all between 1 and 10. They have to be less than 10, but they could equal 1. But they're all between 1 and 10. Okay, and we look at these exponents, we see that they're all integer values. In this case, they're all positive. But they don't have to be positive. For example, 0.0006. Okay, let's look at this. This is tenths, hundredths, thousands, 10,000ths. This is really 6 10,000ths. Okay, so this is really 6 over 10 to the 4th. Remember from our exponent lesson, if you move from denominator to numerator or numerator to denominator, you change the sign of the exponent. So if we want to write this up here, it would be 6 times 10 to the -4th. So in this case, the exponent's negative. But this is a little bit of a hassle to get from a given number to scientific notation. There's a much quicker way of doing it. So look at the number 3,000, right? We know that we want an integer value, or it doesn't have to be an integer value, but it has to be between 1 and 10. So right now the decimal point's here. We're going to move it over so that we just have a number between 1 and 10. So 3. And we know it's going to be times 10 to something. We went from 3,000 here to 3. So we took a fairly large number and made it much smaller. Okay, we moved this 3 decimal spots. So to make up for it, we have to multiply it by 10 to the third. This is a positive 3 up here. Let's look at another one. 5,000, or let's make it 54,000. Again, we need some number between 1 and 10. So it moves over 1, 2, 3, 4 spots. So 5.4 times 10 to the something. We move this decimal 4 spots, so 10 to the 4th. Okay, now let's look at what happens if we have a small number. Alright, let's move this decimal over until we get a number between 1 and 10. So we have 2. Okay, it's going to be times 10 to something. We move this over 1, 2, 3, 4 spots. Okay, but we went from a small number to a larger number. So to make up for that, the fact that we made this bigger, or appear bigger, we have to counteract that by making this a negative. So if we look at these, we went from big number to a small number. So we counteracted that by having a positive exponent. Now we're going from a small number, changing it to look like a large number. So to counteract that, we have to have a negative exponent. One more example. 0.0056. Alright, so let's move our decimal. Move it 1, 2, just 3 spots. So it comes right after the first digit. So we have 5.6 times 10 to the third, because we moved it 3 spots. But again, we took a small number and made it larger, so we have a negative. Another way you could think about this is, if we move the decimal to the left, then that means we're going to have a positive exponent. If we move the decimal to the right, then we're going to have a negative exponent. I like to think of it as, if we go from a large number to a small number, we have to make up for it with a positive exponent. If we go from a small number to a larger number, we make up for that with a negative exponent. But either way, memorizing it is fine. Just whatever helps you do it correctly.